So now let's continue on and talk about integration with the VMware Virtual Distributed Switch. So how does the ACI Fabric and the VMware VDS integrate? Well, how does ACI Fabric implement policy? It assigns endpoints to endpoint groups. What are the endpoints in a virtual environment? They're VM NICs, virtual machines really, but VM NICs are how we see the fabric or how we see the endpoint really. And then how does VMware apply network configuration through port groups, as we began to talk about? How are endpoint groups exposed to VMware? We do these by mapping endpoint groups to VMware port groups. And really, when we create a endpoint group in Cisco ACI, it creates a port group in VMware. And we'll take a look a little bit later in kind of the next subpart of this main module at how we can do everything from the VMware side. And this portion of the module is really looking at how we do things from the ACI web user interface or through the programmatic API interface. But how we do things from the ACI side, we'll, like I mentioned, take a look at how we do things from VMware. So how do we identify endpoints? Well, we can certainly identify physical endpoints as bare metal servers or routers or even switches or firewalls or anything else. And virtual endpoints, the APIC admin is going to talk to the VMware vCenter, or optionally if the customer is running vShield. And as we create an endpoint group in the APIC, it will, as I mentioned, create a port group with a corresponding VLAN ID if the customer is using vCenter, or if we're using vShield, it will create a VXLAN ID. So let's take a look at kind of the flow of how this works from the APIC admin and from the VMware virtual infrastructure or server admin perspective. Now, it might be that these are one and the same roles. Certainly in a lab environment, this will be the same person, but in a larger enterprise corporation, it might very well and typically will be separate people holding these roles. So the APIC admin is going to log in to the web interface or through REST API, and they're going to create a VMM domain. They're going to provide vCenter IP address and credentials, and when they do so, that's going to reach out to the vCenter server, and they're essentially going to do an initial handshake. That's also, that's also subsequently what's going to trigger the creation of a distributed virtual switch. So the APIC, when it creates a VMM domain, it logs in, does a handshake with the vCenter, and essentially creates the, and this is kind of automating on its own. I didn't really want it to go step by step. Wanted to do on next click. But the APIC is going to create the VDS. Then the server admin, it will be their responsibility to attach the hypervisor to the VDS. And we're going to talk about how the ESXi learns. This is going too fast for me. I apologize for the ACI Fabric is going to learn about the ESXi either through a discovery protocol like CDP or LLDP, or a new method that we have in ACI 1.1 called pre-provision. So we'll talk more about that where we don't need a discovery protocol. The APIC admin is going to create an application policy with its corresponding endpoint groups, and it kind of went too fast again. As it creates those, as the APIC admin creates those endpoint groups, those are going to push down and automatically map and assign the VLAN to the port group. So it's going to create the DVS and create the port group in the DVS, assign the VLAN ID to the port group, and then it's going to be, those will be created on the distributed switch. Then it will be the VMware's responsibility to instantiate or bring up virtual machines and to assign those to the port groups. So basically what the VM admin needs to do in this scenario, and again we'll talk about a different scenario where the VM admin does everything in a moment, but in this scenario the VM admin is essentially going to see the new virtual distributed switch, or DVS, distributed virtual switch, and it's going to attach the hypervisors to that DVS. And then they're also going to, as they bring up VMs, assign the port groups that were pushed from the APIC, assign those to those DVS port groups. And then the APIC will automatically, not done by either administrator, as it sees in the, and we're going to talk about two different things. We're going to talk about data plane learning and control plane learning. So control plane learning can and is by default and in the legacy mode done through a discovery protocol. We learn about the hypervisor, and so that's the control plane. And then the data plane is when we actually see, let's say, a web VM or an app VM or a DB VM or whatever kind of VMs we have, as we actually see those come in through the wire with their .1Q VLAN ID that we know about because we created the port group with the VLAN ID based on the EPG automatically creating that port group and automatically assigning a VLAN ID, or we can statically assign a VLAN ID. As we see that data ingressed into the leaf, the APIC on demand pushes policy. Now we'll talk about how policy is pushed. We've talked a little bit about it already. We can do it either immediately or on demand. On demand obviously gives us greater TCAM space, so greater scalability, but we can go ahead and do it immediately. Now, as I mentioned, one of the central things that we'll be talking about is this control plane learning, where historically in 1.0, 1.04, ACI had to see either CDP information or LLDP, so some sort of discovery protocol information related to the ESXi hypervisor. If it did not see that, didn't have that control plane learning, then the VMs could transmit traffic all they wanted. The .1Q tagged Ethernet frame would reach the leaf, and the leaf would essentially disregard it altogether. And the APIC would never learn about these VM endpoints. So that was in 1.0. In 1.1 and later versions, we still have the option of using CDP and or LLDP. Really not and or LLDP. You never want to use both. But we don't have to any longer. So the default is, if we just leave the checkboxes or really the drop downs to the default, that's the default, is that it requires discovery protocol learning of the hypervisor. But we have this option of now pre-provision where we don't need any discovery protocol. So this is very nice. It also used to be that as an EPG was created, it had to pull from a dynamic VLAN pool and automatically assign the VLAN to the port group that was pushed as a result of the EPG creation. That was somewhat problematic for a lot of migrations where if I had an existing, we'll just use VLAN 10 again, if I had existing VLAN 10 outside the fabric and inside the fabric, you're telling me I need to vMotion and I'm going to attach it to the new DVS and then vMotion so it stays kind of running and live, and that's fine. But when I move it to the DVS, it now has a different VLAN ID that I either have to provision outside my fabric or vMotion it over and then change the port group inside the fabric. And maybe it's the same layer 2 broadcast domain, bridge domain, and therefore subnet, but I have to, it's technically a different VLAN ID. So troubleshooting becomes a little bit more difficult, even if it all works just fine. So we now also in 1.1 have the option of manually choosing or statically assigning the VLAN ID that we want, so that the VLANs outside our fabric and the VLANs inside our fabric are the same VLAN ID. Troubleshooting is a lot easier. Migrations are a lot more smooth now. So taking a look at staging the VMware integration, if we see the APIC admin, they're going to create the VMM management domain in the APIC. This is going to create the DVS, push to VMware vCenter. The VI admin or VM admin is going to add the host to the DVS like we mentioned. And then a application will be created. The EPGs that get created in the application profile get pushed to VMware. And then the vCenter admin instantiates the VMs, or maybe they have existing VMs, and they map those to the port groups. And then that gets learned by the fabric, and we have traffic at this point after policy is downloaded. So if we take a look at endpoint discovery, we mentioned already that virtual endpoints are discovered for reachability and policy purposes via two different methods, or historically really two different methods. The control plane learning, first of all, is an out of band, and we actually have an animation that's going to go over this in a little bit more detail. But there's an out-of-band handshake that's done from the APIC to the vCenter or to whatever VMM management, Microsoft's System Center, Virtual Machine Manager, whatever, through APIs. So for instance, APIC talks to and does a subscribe to the actual vCenter server, and then as things change on the ESXi host that is joined to that DVS, the ESXi host tells the vCenter, and the vCenter then tells the APIC, and then APIC now knows about the control plane learning. The data plane learning is done where we learn about the distributed virtual switch, and we then actually have traffic that's passed. Now, there are other options. So we already talked about LLDP and CDP. We talked about now we have the option for pre-provision, where we basically say anything that's attached to the AEP, the attachable entity profile, or if you remember that AEP, software glue that I talked about, any port on any leaf switch that's attached there, if we see a VLAN ID that we either statically assigned or was dynamically assigned when we created the EPG, the endpoint group in ACI, and assigned it the VMM domain, and either statically assigned the VLAN or let it dynamically pull. If we chose pre-provision, anything we see on that AEP attached VMM domain, we're going to trust that it is essentially coming from a hypervisor, and we're going to go ahead and map it to this EPG. Now, another option for this is the OpFlex protocol, and we're going to talk about this more in detail later, so I'm going to save that, but that's another control plane learning that we will have happen. Now, the control plane learning actually has to occur if we're using CDP or LLDP. We have to get the API information from the vCenter to the APIC, and then we also have to see that CDP or LLDP from the actual traffic, so really in band in terms of inline from the host to the leaf switch. So taking a look at endpoint status, if we are in our web interface and we are on the tenant tab, we're in any specific tenant where we've created an application profile and one or more EPGs, if we're on a particular EPG, we will have first clicked down here under domains, VM and bare metal, and we'll have associated a VMM domain. And when we did that, this is where we would have chosen the option for either pre-provision or on-demand or immediate. If we choose either on-demand or immediate, then we have to have CDP or LLDP. If we choose pre-provision, we don't. Here, optionally, we can put in a VLAN ID as well. If we don't, it's dynamic. If we put one in, it has to come from a static pool. Then up on the main EPG, after we're gone away from the policy tab over to the operational tab and client endpoints, we see that we've learned about two VMs, T1 Win7 and T1 Win7 VM1 and VM2. And we have two different learning source methods. So we see VMM and learned. VMM means that we got the information from the APIC, and we have most likely CDP information about this. Learned is the data plane learning. So we've actually seen traffic ingress to a leaf switch on whatever VMM domain attached AEP ports and switches. And we've seen it come in this case, on leaf 101 port E11, and this VM on leaf 102 port E12 with this particular encapsulation, VLAN 1167. Okay, so if we only see VMM, then we probably don't need to troubleshoot CDP. We probably have a data plane learning information problem. Maybe the VLAN isn't allowed to go on the trunk from either the ESXi to the leaf, or if there's an intermediate switch, which we'll talk about, then maybe it's not allowed on that trunk. If we only see learned, but not VMM, which is much more common, then we have seen traffic come in on a particular leaf and port that our VMM maps to from an AEP perspective, and with a particular VLAN tag. However, we didn't see CDP information or LLDP. So at this case, we don't have VMM, and the traffic will not be allowed to pass. So this is still an issue. Now, again, if we did pre-provision, the VMM requirement goes away. We don't even see this VMM. All we see at this point is the learned learning source. Okay? We'll still receive information about the hosting server. So this is the ESXi node, the ESXi management interface, the VMK0 interface, and what the name, whatever we named it, so we just named it something generic here called vCenter. I'm sorry, actually this is the controller type. This is just the type of vCenter or Microsoft System Center. But then we have the reporting controlling name, so tenant 1 vCenter, tenant 1 vCenter. So this is actually the name that we called it here in the APIC, not necessarily what the vCenter is named from VMware's perspective. So again, the attachable entity profile, or AEP, must be mapped to the ports. So the AEP, if you remember back to our diagram, is what points or links associates to the VMM domain. And then assuming we're still using discovery protocol, the ESXi host discovers the neighbors via LLDP or CDP. It doesn't matter which. It communicates this information to the vCenter, the ESXi host does. So it says I'm connected to leaf 101 port 10 and leaf 102 port 10, maybe a VPC. Might not be VPC, in which case we wouldn't be using LACP. We'd probably be using MAC pinning. And we'll talk about when that's going to be specific or important. And then the vCenter is going to tell that to the APIC. The APIC is also going to resolve that, hey, on those leaf switches, I see the ESXi host, and so we're good. So here's one of the things that we need to keep in mind if we're using discovery protocol learning. So if we're using LLDP or CDP, the ESXi discovery through UCS B series has a little bit of a unique situation. Now, two things. First of all, in, I believe it's UCS Manager 2.2.4, if I recall correctly, there, as of the time of this recording, is relatively new, and it finally supports the blade that's kind of indicated here by the VMware ESXi host, the blade up to the fabric interconnect, so really through the chassis, through the I/O modules or FEXs in the chassis, up to the UCS fabric interconnects or FIs, which is what these are. It now supports LLDP in the network control policy, and that's under the network or NIC tab, okay? Or actually LAN tab in UCSM. It used to only support CDP, and the reason was that LLDP was reserved on the UCS fabric, from fabric interconnect down to the blade, for FIP, Fiber Channel over Ethernet Initialization Protocol. It's now, they've worked out a way to get that information to the blade and to allow FIP to discover the FCOE VLAN, but also pass the traffic on to the hypervisor. But before, that wasn't supported. So you could use CDP here, but note that the fabric interconnects sort of act like switches in some fashion, in the sense that information is not passed from the host all the way on to the leaf switch in terms of discovery protocol. So the discovery protocol only goes from the ESXi or whatever blade you're running that supports CDP or LLDP. It only goes up to the FI. So the ESXi learns about, hey, I'm connected to FIA port 13 and FIB port, let's say 13. And then the ACI leaf switch, they learn, and this can actually be via CDP, or it's actually recommended if you're doing this to have this leg from the leaf to the FI to be LLDP, even if the leg from the FI down to the blade is CDP. Doesn't matter, it's still discovery protocol. And the APIC actually takes and stitches this information together. So the ESXi, in fact, I think we have another slide on this. Here we go. I'll come back here in a moment. The ESXi, and actually I will just go back real quick. So this is done through the configuration on the side of the APIC. This is done through a VPC interface policy group, and specifically will enable one protocol and disable another. Maybe LLDP will be enabled on the VPC interface policy group, even though here it shows disabled. Maybe it will be enabled and CDP will be disabled. But then under the, it kind of looks like it's a subset of the VPC interface policy group. It's not. Under the AEP, there is something called an AEP vSwitch override policy, and we could actually disable LLDP and enable CDP, which results over here in VMware that the networking DVS, distributed virtual switch, for that port group under the port group settings for advanced shows CDP is enabled for both transmit and receive. And so as a result, what happens is the leaf detects the fabric interconnect, the ESXi host detects the fabric interconnect, and the APIC stitches or correlates the two bits of information together to understand which fabric interconnect port is providing connectivity between the ESXi host and the APIC. And like I mentioned, they don't even have to be the same discovery protocol. So hosts are assigned VLAN IDs through the VMM integration. Now we have the option of having intermediate layer 2 nodes. So we just got done talking about this from the perspective of, for instance, the UCS chassis with its I/O modules, talking to fabric interconnects, and really those fabric interconnects looking like switches or L2 switch, kind of a separation from the leaf to the blade. So that's one option. Another option is that maybe we just have a bare metal server, for instance, and the possibility is there that the leaf switch is connected through another external. Maybe I have a pair of Nexus 3000s or 5000s or even a 2960, Catalyst 2960, some other unmanaged by the fabric layer 2 switch. And again, we can do LLDP or CDP stitching by saying we're discovering this switch, and as long as this is a hypervisor, we're discovering this switch, and the vCenter is telling the APIC about this. The APIC sees the leaf is discovering the same switch, and so we have the correlation. But again, with pre-provisioning, this kind of makes all of this point moot. So a lot of customers are using pre-provision now.